Okay, let's do trigonometry of triangles, but this time we're going to work with variables and not numbers. So what I want to point out in the diagram is that we've got alpha, beta, theta, and x. We've got no actual numbers for the angles or for the sides. So let's start with the information they give us. They tell us in the sketch, AD is a vertical line. The moment I see vertical line, this one, I am going to insert a 90-degree angle. So, my colors are different here, okay? So that one here is 90 degrees. That's my first sentence, vertical line. Next thing, let's see if we can change the colors back though. Okay, so we've got our yellow line, we've got a 90-degree over there. Next up, second sentence, so that's our vertical line. They tell us ABCD is on the horizontal plane, so that's the gray one. That makes sense to us. ADC is alpha. So if that one's alpha, if we do that one in green, then I want this also in green because I like to have opposites for my sine rule, right? To have the same color. So that means that that's X and that's alpha. We're fine with that. Next one, they're telling me this is beta, which makes this one pink, which is great. And then our third one is going to be, this one's theta. Okay, so our beta statement's there, and our theta statement is this one, and that's this one. Oh, so my theta is the opposite of my yellow, right? AD and theta go together. Beautiful. So we understand. We've got two triangles. Let me resketch. Okay, I've resketched it. Now the question number one is saying, show that AD is x sine theta, x sine beta, tan theta divided by sine of alpha. Okay, where do we want to be? AD is our yellow line. So show that the yellow line is something, something, something. If I use my colors, I can see beta is pink, and theta is going to be my yellow one, and alpha is my green one. Okay, so somehow these things are connected. I want to prove AD. So how do I figure AD? Remember, I always have a couple of options. So I could use SOHCAHTOA, but for this to work, I need a 90-degree angle. I can use the sine rule. I can use the cosine rule. And I could use Pythagoras. And for Pythagoras, I need 90 degrees. So I'm going to go through the possibilities. I'm starting at the end. For me to get AD, this yellow line, I could go, if I use the sine rule over here. So I'm thinking, I'm not answering, I'm thinking. I could say AD over sine of theta, that's doable, is equal to, now what do you want to do here? Because now you've got options. If we use DC, I need that, because DC goes with that one. Or I could use my hypotenuse, which goes with that 90 degrees. So those are my two options. Which one would make more sense? The one that would make more sense is this DC. Oops, wrong color. And the reason why is because DC exists in both triangles, right? So I've got DC here and I got DC here. So I'm going to go with DC. So this is equal to DC over, now we've got two DCs in two different triangles. That's why we say in triangle ADC. So in ADC, it's DC over sine of whatever angle A is, but we don't know what angle A is. So if I do a little checklist, I can say this is fine because it's unknown. That's fine. DC is unknown. Hold on one sec. DC we don't know, and sine A we don't know. So there are two things. All of that is unknown to us. Okay, let's look in our second triangle. in triangle BCD, what do you have? Now, already we have two colors, so that's brilliant. That makes life work for us, right? Okay, so if in this triangle, if I use the sine rule, I can say that DC is what I want, right? DC divided by sine of beta is equal to BC divided by sine of alpha. Okay, on this, what do I need? What do I have? I have this, I have that, and this I can replace with x. So I have that. This second equation can be worked out. So at this point, peace on earth, we are okay. If I solve the second one, I will have DC, which is great. So once I have DC, I can substitute it there. What about that sine of A? Okay, we'll come back to that. Let's answer this question. So this was us thinking. I'm going to start with the second one. And I'm going to say, okay, my answer is exactly the same. I don't actually have to rewrite it. B, C, D, starting there, I'm saying DC divided by sine of beta is equal to x divided by sine of alpha. Therefore, DC is equal to x sine beta divided by sine of alpha. Yes, I'm happy with that. That's brilliant. Now I'm going to take this to my second statement, right? Now, let's quickly go to what the question is asking us to do. So it's x sine beta tan theta divided by sine of alpha. Now let's compare x sine beta, we're on the right track. Sine of alpha, we're on the right track. The only thing that's missing now is tan of theta, and that's what we're going to get from the second one. Okay, so I'm going to say in our second triangle, ACD, in triangle ACD, what are we doing? We are going to say that AD, which is our final answer that we want to answer, divided by sine of theta is equal to DC divided by sine of A. That is the sine rule. Okay. That's where we started. But now, on the side, just me thinking, what is tan of theta actually in this triangle? Tangent, according to SOHCAHTOA, is going to be opposite over adjacent. So if I'm looking at tan of theta in this triangle ADC, opposite is AD and adjacent is DC. Okay, that's beautiful. Tan of theta is AD over DC. Now, can I actually use those? Do I know what each is? So let's double check. Do you know what AD is? Well, AD we're trying to solve, right? So AD we're trying to solve. But what about DC? You know what DC is. DC is right here. DC is all of that. So we have DC. Okay. So if I rearrange this, okay, let's have a look. See. Still continuing with my thinking here on the right, I'm going to say tan of theta is equal to AD divided by x sine beta over sine alpha. Yes, 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 no, yes, no. Well, no, I can just take that. If I take that as tan of theta, then I can make AD the subject here. What if we made AD the subject here? We say AD is equal to tan of theta multiplied by DC. Would you agree with that? Okay. And what is DC? DC, tan of theta, DC is over here in purple. DC is, so I'm multiplying here with x sine beta over sine alpha. And that is exactly what the question is asking us. That is the proof. So if I rewrite it, AD is equal to x sine beta over, or times tan of theta divided by sine of alpha. So we ended up not actually using that. We used this tangent statement over here. We used this tangent statement and we explored that. Okay, so that's how you answer question A in 1. Next video we'll answer question 2.